Welcome to Physics World Online College, where we simplify the concept of physics and make you understand it easily and also pass your exams. Please remember to click the subscribe button if you have not done so, and share this class video with your friends on WhatsApp and Facebook, TikTok, and other social media handle. In our class for today, we will look at types of capacitor. But I want to distinguish this from the one I said in the last class. This type of capacitor is based on the construction or type or nature of the insulation or dielectric material. So we say, if the dielectric material is made of air, we will call it a capacitor. If it is made of paper, that is, you have paper between the two conductors, you call it paper capacitor. If the dielectric material is made of mica, you call it mica capacitor. If it is made of ceramic material, you call it ceramic capacitor. If it is made of a material where you can vary the value of air, you call it variable what? Capacitor. Then if it is made up of electrolyte, you will call it electrolytic capacitor. This electrolytic capacitor is very special because it has specified polarity. That is a question they normally ask. They will ask you, which of the following types of capacitor has specified polarity? Please, it is electrolytic capacitor. So hence I gave you the word, the symbol, and the schematic diagram for the electrolytic capacitor. So the dielectric material there is what? Electrolyte. Now, we said in our last class that capacitor stores energy in form of electric charge. I also want to add that capacitor stores electrostatic energy. Take note of that. And we can also call capacitor condenser. We also call capacitor condenser. Now, let's talk about the three factors that will affect the capacitance of a capacitor. There are three factors that determines or affect, that determines the capacitance of a capacitor, that determines the capacitance of a capacitor or condenser. Number one is what we call the common area of the plate, or you can call it the area of cross-section of the plate. Number two is the distance between the two plates. Or you can call it the distance of separation between the plates. And number three is the nature of the dielectric material or insulating material between the plates. Now, this will be represented by the permittivity of the material. Now, how does these three factors affect the capacitance of a capacitor? Firstly, the area of the plate. The capacitance of a capacitor increases with increase in the area of a cross-section of the plate. Take note, an increase in the area of the plate increases the capacitance. What does that mean? It means with a bigger area, you will be able to store more charges in the capacitor. Two, the area here involves the size of the capacitor and the shape of the capacitor, which have direct influence with the previous classification I gave you about the capacitor, that if the conductors are plain, then you will call it parallel plate capacitor. Then if the the conductors are spherical, you will call it spherical capacitor. Whereas if the conductors are cylindrical, you will call it cylindrical capacitor. Remember. Then we say for the distance of separation, the capacitance is inversely proportional to the distance between the two plates. What does that mean? If I want to increase the capacitance of a capacitor using the distance, then I'm going to what? I'm going to reduce the distance, because the smaller the distance between the plates, the more the capacitance of the capacitor, that is, the more charges it will store. I hope that information is taken. Please, these questions are normally asked. They will ask you which of these is or are affect the capacitance or determine the capacitance of the capacitor. Here, the area is increase of the area will increase the capacitance. Here, it is decrease of the distance that will increase the capacitance. So when you see such question, you know how to answer. Then, as for the nature of the dielectric material or insulating material placed between the plates, we say that this is denoted using the permittivity of the what? Of the material. And I've said previously that the permittivity, no, I said previously that the, what's it called? The nature of the dielectric, the purpose of the dielectric is to increase the capacitance of the capacitor. So which means it has a direct effect on the capacitance of the capacitor. Here, so let me do this. I'm going to combine. Let me call this equation 1. I call this equation 2. Let me combine equation 1 and 2. Combining equation 1 and 2 gives that the capacitance is directly proportional to the area and inversely proportional to the distance between the two plates. If I remove this proportional sign, I'm going to put a constant together with the equal to sign. And that constant I'm putting now is what? The permittivity. This permittivity represents the nature of the dielectric. This permittivity represents the nature of the dielectric material or insulator placed between the what? The plates. Now, I call this equation 3. Equation 3 will be used when we know the permittivity of the material. But this permittivity of material, we can be given the relative permittivity and then the permittivity of a vacuum to determine the word permittivity of the material. Then we need to get another formula which I will give you shortly. Let me define what each of these means. Where I said A is the word cross-sectional area or area of cross-section. Cross-sectional area of the plate. By the way, it has to be in meter square. So if the unit in a question is not in meter square, please, you will have to convert it to meter square. 2, being that it is area, now the type of the word of the conductor will influence the formula you may use to obtain the area. If it is what? A plain conductor, you can use pi r square in questions where they give you radius. And then there are other questions they can give you a name, maybe cylindrical shape. They give you formula. You use the formula for area of a cylinder or a sphere. You use the formula for area of a sphere to determine the cross-section area of that plate. So all those other information are intertwined here. So area here is the area of the plate. As I've said, any of the formulas for obtaining area of a specific shape is applicable here, if that shape is what is used as the conductor. Please take note. Then we have D as the word distance of separation between the plates. Distance of separation between the plates. Of course, this distance will be in meter. In meter. So if you are given in unit that is not meter, you are expected to convert to meter. Then I said here epsilon represent permittivity. We call it the permittivity of the material, of the dielectric material, permittivity of the dielectric material. Of course, representing the nature of the what? Of the dielectric. Good. So now I said there is a relationship between relative permittivity of a material, the permittivity of the material, and the permittivity of air. Observe what I want to do. Note that the relative permittivity is permittivity of a specified material divided by the permittivity of air or vacuum. Permittivity of free space or vacuum. Now, if I put it in symbol, relative permittivity, I will call it epsilon r. Permittivity of that specific material, I call it this epsilon. And then the permittivity of air, I call it epsilon 0. Good. Which means in a question where I know the relative permittivity and I know the permittivity of air, if I cross multiply, call this equation 4. If I cross multiply, I'm going to have that the permittivity of that material will be equal to the relative permittivity multiplied by the permittivity of what? Of vacuum. Let me call this equation 4a and this 4b. Now, which means I can substitute equation 4b into equation I can substitute equation 4b into equation 4, equation 3. If I do that, then the formula for the capacitance will be substituting equation 4b into equation 3 gives. What is equation 3? We say equation 3 is capacitance is equal to permittivity of that particular material multiplied by the area divided by the distance. If I substitute this relative permittivity, the permittivity of air, I will have that the capacitance is what? Relative permittivity of air multiplied by area divided by the what? By the distance. Let me express it here so that it will be clear for you to see. This is what I'm saying. Equation 3 is capacitance is permittivity of the dielectric multiplied by area divided by what? The distance. Now, in place of this permittivity of the material that is known, I will replace it with what? Relative permittivity and permittivity of vacuum. That will give me relative permittivity of vacuum, area divided by what? D. So this is equation 3. I will call this equation what? 5. Because this is equation 4. I call this equation 5. Now, what is the difference between equation 3 and 5? I will use equation 3 if in the question I'm giving the permittivity of a known material. For example, it is water. For example, it is air. It's not water. If it's air, if it's paper, or if it's mica, It means the material is known. I'm giving the permittivity of that material. We use equation 3 straight. However, if in the question they give me the permittivity of air and relative permittivity of a particular material, then I can use equation what? 5 directly to obtain the permittivity of that material. Now, one more thing. For vacuum, if the dielectric is air, for air, the relative permittivity is equal to 1. The relative permittivity of air is what? Is 1, which means if I put 1 here, what I will have, equation 5 will now be written as C equals epsilon 0 area multiplied by epsilon 0 multiplied by area divided by what? The distance. I will call this equation what? 6. Once again, I will use equation 6 if the particular dielectric is air. I will use equation 6 directly. I will use equation 3 if I am given the dielectric of the particular material straight. Or I will use equation 5 if they give me the relative permittivity and then the permittivity of air. I'll use equation 5. So these 3 equations will be applied in solving these examples that we have. I believe there is clarity in the use of the equations as I have explained. So let's apply it. So you see how it is done. Good. So solution to example. So we are given from the question the area of what? Of the plate is A equals 0.025 meter square. I said if they give you unit other than meter, you have to convert. So in this assignment, I expect you to convert this cm square to meter square. Then we are given in the question the distance between the plate as 0.0002 meter. Once again, if the distance is given in other units aside meter, you have to convert it to what? Meter. So they want us to get a what? The capacitance. Here we have 3 different mediums considered. First one is if you have air inside as a dielectric. Second one is if you have a specified material given is dielectric. Then if you have the relative permittivity of a material given to you, how do you obtain it? Let's see that. The first one, we are given that it is air. So the permittivity of air, epsilon 0, is given as 8.85 times 10 raised to the power minus 12 farad per meter. So which of the formulas am I going to use? Is it 3? Is it 5? Is it 6? Since it is air, I will use equation what? 6. So I will say C is equals to epsilon 0 area divided by what? The distance. If I substitute, I will have 8.85 times 10 raised to the power minus 12 multiplied by the area 0.025 divided by the distance 0.0002. If you multiply and divide, you are going to have 1.11 times 10 raised to the power minus 9 farad. That will be your answer. Now, this unit, I can re-express it. 10 raised to the power minus 9 is actually nano, which means I can put it as 1.11 nanofarad. Do you get that? Nanofarad with small letter n. That is also acceptable. Then if I don't want to put it in nanofarad, I want it in microfarad, then I will have it as 1.11 times 10 raised to the power minus 3. Then I will say microfarad. So all of these are different way of expressing the unit of capacitance. But I have said in the last class, the SI unit is actually farad. All these other ones are just simple way of representing the units or submultiple of the units. Let's take the second option. They say if it is now made up of a known material whose permittivity is given. So in this one now, this is not vacuum. It's a particular material, which means you are given the permittivity of that known material is given to us as 7.0 times 10 raised power of minus what? 8 farad per meter. To find the capacitance. Here, I will use that the equation 3 to get the capacitance. So C will be permittivity of the material multiplied by the area divided by the distance. Once again, I will substitute 7.0 times 10 raised power of minus 8 times the area 0.025 divided by the distance 0.002. Once you multiply and divide, you are going to have it as 8.75 times 10 raised to the power of minus 6. You have this as 8.10 to the power of minus 6 in farad, which you can re-express as 10 raised to the power of minus 6 is micro, so 8.75 microfarad. So mind you, why am I doing this other representation is to enable you know how to use them. When we discuss in the next class series and parallel connection of capacitor, when you are given a capacitance in microfarad and you are to calculate charge, for example, you cannot use it with this microfarad still there. You have to remove this micro by multiplying by 10 raised power of what? Minus 6. So you have to take note of that. I will talk about it later. Let's look at the last option there. Then they say if the dielectric material now, if we are given the relative permittivity as 3. So here epsilon arrow is given as what? 3. And then of course the permittivity of vacuum is also known because they go together in this essence. So 5 times 10 raised power of minus 12 farad per meter. So like I said, here now, to get the capacitance, I will quote the other formula, which is C becomes relative permittivity of vacuum multiplied by area divided by the what? Distance. Do you understand? Okay, I substitute now. I will have 3 times 8.85 times 10 raised power of minus 12 times the area, which is 0.025 divided by 0.0002. If you multiply and divide, you will have 3.33 times 10 raised to the power of minus 9 farad. Of course, which you can write as 3.33 nanofarad, or you can write as 3.33 times 10 raised to the power of minus 3 microfarad. Good. Any of these are correct answer for the capacitance. Good. So I have the assignment that you will do 1 and 2. You will do it and submit to me. I will cross-check it and get back to you. I'll see you in the next class. Bye.